Hello my dear you all, I am Rakesh away from Sunbeam Sun City. My dear, today I will give you a knowledge and the formula of velocity of image in spherical mirror. Earlier I have given you about plane mirror, that how to find velocity of image in plane mirror. Today first I will give you the formula, derived formula to find velocity of image in spherical mirror, and then we will apply that formula to one or two numerical problems also, so that we will working on it, that the formula is really working to get the answers for velocity of image. Now my dear, to derive this formula, let us take, you all know that according to mirror formula, you all know that 1 by v plus 1 by u is equal to 1 by f. Now here, let me tell you, u is your object distance. Please make a note of this, that this is distance. V is image distance. And f is focal length. F is focal length of mirror which is always constant. Please make these three things very important. U is object distance, V is image distance, and F is focal length of a mirror, sir, and that is remain constant. Because focal length once given for any mirror, for concave mirror, if focal length given numerical 20 centimeter, that will remain constant. But object distance and the image distance will keep on changing. When object distance will change, immediately the image distance will also be changed. Please take care. U changes when object distance changes, image distance also changes. V also changes, right? But focal length is remain constant. Okay. Now, can I write down this as v power minus 1 plus u power minus 1, because this is in reciprocate it. So, power minus 1 plus u power minus 1 is equal to f power minus 1. Please make a note of this. I reciprocate the mirror formula. Now, my dear, let us differentiate this. Differentiate with respect to time. So this will be d by dt, v power minus 1 plus d by dt, u power minus 1 is equal to d by dt, f power minus 1. You can see. But my dear, you all know that f is constant, focal length is constant. So derivative of constant is 0. Derivative, you know, derivative of constant is 0. You all know. So focal length is constant, so derivative of that will be 0. Rest all, my dear, you must be knowing the formula here. What is the derivative of d by dt of x power n? D by dt of x power n formula is n into x n minus 1 dx by dt. कैसे किया? You all know the formula. Sir, this is n. So n will come on this side. So this is n x पावर में क्या हो जाएगा? एक पावर कम हो जाता है, n minus 1. और डेरिवेटिव में दिस अल्फाबेट इज x, सो फर्दर आई विल राइट dx by dt. ठीक है, बिकॉज हियर द x इज नॉट डिफरेंशिएट विथ x, हियर x इज डिफरेंशिएटिंग विथ टाइम, सो फर्दर इट विल बिकम एज dx by dt. अगर ये x के डिफरेंशिएट होता तो हियर आंसर इज 1, राइट? हियर द आंसर इज 1, dx by dx हो जाता. बट हियर इट इज dt एंड देयरफॉर आई नीड दिस स्टेप, that after taking derivative of x power n, how much is the answer? N into x power n minus 1 into dx by dt. So using this formula here, what will be the answer for this, my dear? This will be minus 1 into v power minus 1 dv by dt plus minus 1 again into u power minus 1 du by dt. This I will get on solving. You can see n, so यहाँ पे n के जगह पे यहाँ n है, यहाँ पे -1 है, so it is -1. Here it is v, here it is x. So I have written v and n minus 1, but here what is there? -1, so this is -1. So I use this formula, my dear. So this will be -1 into v power -2 dv by dt plus -1, right, u power -2 du by dt is equal to 0. Now this can be written as, my dear, -1 upon v square, this v power -2 will come in denominator, dv by dt, I hope it is clear, minus, here also minus, 1 upon, this plus and minus become minus, this is 1 upon, this become u square du by dt is equal to 0. What will be the next step? This will be, my dear, I can write this as minus 1 upon u square du by dt. I have kept this on this side as it is equal to this, go on this side, and this will become 1 upon v square dv by dt. This will give me, my dear, you can see here, please take care, you can find out over here, what is du by dt? What is du by dt? U is my object distance. So change in object distance with respect to time. I repeat, du by dt matlab change in object distance, this is u upon dt, that is change in object distance. So this will become -1 upon u square into velocity of object is equal to 1 upon v square, and this is v. V is what? Image distance. Image distance. So change in image distance with respect to time will become image velocity, that is vi. So now the formula will become, my dear, the formula will become therefore vi upon vo, yeah, vi is equal to minus v square upon u square into vo. You can see here, this is the speed of image with speed of object, or you can say velocity of image is related with minus v square upon u square into velocity of object. So once again, my dear, you can see the step. I have used the formula 1 by v plus 1 by u is equal to 1 by f. But here, let me tell you, here this formula is taken, mirror is at rest. Why I am telling this mirror is at rest, I am coming to that point. But my dear, when I use this formula according to mirror formula, this is the formula 1 by v plus 1 by u is 1 by f. I have reciprocated, it is v power -1 plus u power -1 is equal to f power -1. I differentiate with respect to time. This is d by dt of v power -1 plus d by dt of u power -1 is equal to d by dt of f power -1. Now my dear, first take the right hand side. You all know that focal length of the mirror is constant. So derivative of constant is 0. So on the right side it is 0. Now to carry out this derivative, I use the formula. You all know that d by dt of x power n, d by dt of x power n का formula है n, ये power जो है that get multiply n into x power n minus 1 into the alphabet x का derivative ले रहा है. So this is dx by dt. So here it will be what answer? This is n का काम कर रहा है -1. So this is -1 into v. So यहाँ n into x था, तो -1 v, and here n -1, so here -1 and the answer dv by dt, because derivative velocity is going for image distance. So that is derivative of image distance with respect to time. Similarly, I apply the same derivative, same kind of method over here, and I got the derivative of object distance with respect to time. And then I solve this minus 1 as it is, this is v power minus 2 dv by dt as it is, plus minus 1 as it is, this is u power minus 2 du by dt is equal to 0. V power minus 2 can be written as minus 1, v power minus 2 can be written as v square. So this is minus 1 upon v square dv by dt plus, and minus become minus, and this is again 1 upon u square du by dt. I have taken minus 1 upon u square du by dt is on this side. This shift on that side will become, the answer will become du by dt is ये important step था. U is what? Object distance. So changing object distance with respect to time is object velocity. Changing image distance with respect to time is image velocity. यहाँ तक clear? Now my dear, if mirror is in motion, so it is relative motion concept, that is object and image both moves with respect to mirror. So here this formula will become, my dear, this is a relative formula. Here also I can use that relative formula. You can see in the previous also I can use the relative formula, right? That relative formula here also I can use. But here the mirror is at rest, so no use of it. Since mirror is at rest, so velocity of mirror Vm is taken as 0. But if mirror is in motion, the formula will become Vim here also I can write the Vim is equal to minus v square upon u square, and this is v naught, that is Vom. So again, my dear, if I solve this, what will happen? This will be nothing but, if I solve this one, this will be nothing but, you all know that this will be nothing but Vi minus Vm is equal to minus v square upon u square. You all know that that is a velocity of image with respect to mirror. So Vi minus Vm, velocity of object with respect to mirror, this will be Vo minus Vm. But since Vm is 0, therefore the formula will become Vi vector. You can say, you can take it as vector, because velocity is a vector quantity, whereas this v and this u are image distance and object distance. Don't get confused with velocity and distance. Here I am using capital and here I am using small. So this will be Vi vector is equal to minus v square upon u square into Vo vector. That is the same formula I am getting as at the top. But if mirror is at motion, if mirror is in motion, my dear, then what will happen? Try to understand. The Vim is equal to minus, this is v square upon u square, this is Vom vector, that is relative motion now. So this will become Vi vector minus Vm vector is equal to minus v square upon u square, and here I will write Vo vector minus Vm vector. This is the formula I suppose to use when the mirror is in motion, and this is the formula we are using. This is the formula we are using, my dear, here when the mirror is at rest. So these are the two formulas, my dear, for spherical mirror. In shortcut you can calculate. I'll show you two numericals also to calculate the velocity of images in spherical mirror. So that's all, my dear, from my side. Now I will take two numericals based on this, and then I will say that I have completed the velocity in both the cases, that is plane mirror also as well as spherical mirror also. So please make a note of this. I am doing this all for you. Please make a note of this. Work hard sincerely so that on 20th, which you are giving the exam, it should be wonderful. Thank you.